Ooh, I like these. These are like a puzzle. So now in this one I notice I'm talking about first derivative. So of course that tells me the slopes on the original graph. And at the same time I can use it to determine the slope, which would give me second derivative. So if I look at this picture and I figure out what's the slope here, and what's the slope here, and what's the slope here, and what's the slope here, then I'll know what's going on with my second derivative. So of course the first question it asks me is where the original function is increasing or decreasing. Well, increasing and decreasing I can tell from first derivative. And so I can simply look at, is it positive or negative? So now from, I'll say less than 0. So f prime is negative between 0 and 2. That's all of this, because it's below the x-axis. And then 3, 4, and then 5, 6, 7 to 8. So 5 to 8. And then it's not negative anymore after that. And instead, it's positive because it's above the x-axis from 2 to 5 and 8 to, let's say, 11. Put a couple more tick marks on there. So it's increasing when it's positive, so that would be the 2 to 5 and 8 to 11. So keep in mind that I'd have maximums and minimums when the derivative is 0, and I'll be able to tell. So I've got a 0 here, and a 0 here, and a 0 here. And I'll be able to tell if they're maximums and minimums based on what's happening around them. So at x equals 2, I'm going from, so changes from, let's see, it's a negative on the left side of it, but it's a positive on the right. So negative to positive. And remember, if my slope goes from a negative to a positive, then this point would be a relative min. So at x equals 2, I have a relative min. Now while I'm at it, is there any other place where I'm switching from a negative to a positive with these yellow or orange dots? Well, sure. At x equals 8, it was negative on the left and positive on the right. So at x equals 8, I would have the same issue. Changes from a negative to a positive, so it's relative min. However, at x equals 5, to the left of 5, I'm positive. To the right of 5, I'm negative. So at x equals 5, the slope changes from positive to negative. So it's a relative max. Positive to negative would look like that. So I get a relative max. So on the next piece, when it's talking about concavity, I want to look at second derivative, but second derivative requires that I take the slope of the first derivative, or I look at the slope of the first derivative. So here, my slope, of course, would be negative, and then I'm going to hit this, and my slopes are going to be positive, and then I'm going to hit this peak, and my slopes are going to be negative, and then I'll hit this valley, and then my slopes are positive, and then peak, negative, valley, positive. So I would be concave up when f prime, double prime, sorry, is positive. I'm going to restart this problem in the next video because I'm almost out of time.